Now, in this lecture, we will see how to determine a plane under some conditions. Okay. So the first one, intercept form of the equation of the plane. Okay. So the theorem is that equation of a plane which makes intercept ABC on the coordinate axis. That means X intercept is A, Y intercept is B, Z intercept. That means your plane curves to the X axis at the point A, Y at B, and Z at C. Then that equation of the plane X is equal to A plus Y upon B plus Z upon C is equal to 1. This ABC are the intercept made by a plane with the coordinate axis. Okay. So we want to prove that this is if a plane makes ABC intercept to the coordinate axis, then the equation of the plane is X upon A plus Y upon B plus Z upon C is equal to 1. Okay. So this we want to prove. Okay. So let the equation of a plane which makes intercepts ABC on the coordinate axis B. So small a is there. So we'll say this is what plus D is equal to 0. This is our required equation of the plane. If you get the values of A, B, C, D in terms of small a, B, C. So what is our aim? To find the values of A, B, C, D in terms of small a, B, C. Because we have provided small a, B, C. You have to find the values of A, B, C, D from in terms of small a, B, C. Okay. So as A, B, C are intercepts on coordinate axis. Therefore, the plane 1 passing through A 0 B 0 B 0 and C 0 0 C. Okay. So therefore 1 implies. So A, B, C are the points on the plane. The plane 1 passing through this. Okay. So that means they satisfy the equation of the plane. So that is what is A into X plus D is equal to 0. Implies that not A into capital A. You have to put small x is equal to small a, P, Y is equal to 0, Z is equal to 0. So this is what then AA is equal to 0. So this implies that capital A is equal to minus D upon A. Okay. So 2 implies that BB plus D is equal to 0. Implies that 1 implies that, not 2. 1 implies that. So B is equal to minus D upon B. 1 implies that C plus D is equal to 0. Implies that your C is same as D upon C minus D upon C. Okay. So what implies? You can put the values of capital A, B, C. That is what? Minus D upon A, X. Minus D upon B, Y. Minus D upon C, Z. Plus D is equal to 0. Plus D is equal to 0. Okay. So you can write this as D upon A X plus D upon B Y plus D upon C Z is equal to D now. Okay. So here all side minus D and you can shift this. So D is shifted to this minus D. All are minus, so all are plus positive. Okay. So I call this as 2 now. Okay. Since the plane intersects 3 axes. So therefore it is not passing through origin. So that means what? It is not passing through origin. So therefore D is not equal to 0. So if any plane or any surface or any curve do not passing through origin, then the constant term will not be 0. If constant term is 0, then that curve, that surface or whatever that, okay, passing through the origin. So it is not passing through origin, that means your constant term is not 0. So D is not equal to 0. Therefore 2 implies that x upon a plus y upon b plus z upon c is equal to 1. This is a required equation of a plane, and it is called intercept form of equation of a plane. Intercept form of the equation of the plane. So that means what? If you have the intercept made by a plane with the coordinate axis, directly you can write the equation of the plane. Directly you can write the equation of the plane. So x upon x intercept plus y upon y intercept plus z upon z intercept is equal to 1 will be the required equation of the plane. Okay. So we take a problem. Find the intercept of the plane x plus twice y minus twice z is equal to 3 on the coordinate axis. Okay. Solution. There are two ways. Okay. So first we will see, given that equation of a plane is x plus twice y minus twice z is equal to 3. Okay. So we'll convert this equation in the intercept form. So I want here 1. So what will I do? So x upon 3 plus twice y upon 3 minus twice z upon 3 is equal to, not 0, it is 1. Okay. So I can write this equation in the form x upon 3 plus y upon 3 by 2. I can write this. Okay. Plus z upon minus 3 by 2 plus minus 3 by 2 is equal to 1 now. Okay. So therefore the intercept made by plane with coordinate axes are 3 by 2 minus 3 by 2. Very simple. Okay. Or to find x intercept, put y is equal to 0, z is equal to 0. If you put y is equal to 0, z is equal to 0, what do we get? X is equal to 3 here. To find y intercept, put x is equal to 0, z is equal to 0. If you put x is equal to 0, z is equal to 0, what is y? Y is 3 by 2. See, this is 3 by 2. Okay. To find z intercept, put x is equal to 0 and y is equal to 0. So what we get there? X is equal to 0, y is equal to 0. Z will be what then? Minus 3 by 2. So minus 3 by 2. So there are two ways to find x intercept, y intercept, z intercept. This is a fantastic way, so that within the two lines you get all the intercept here. Okay. Find the equation. Find the equation of the plane whose intercepts on the coordinate axis are 1, 3 by 2 minus 2 by 3. Okay. Solution. Given that the plane makes intercepts on the coordinate axis are 1, 3 by 2, minus 2 by 3. Therefore, by intersect form, the equation of the plane is x upon 1 plus y upon 3 by 2 plus z upon minus 2 by 3 is equal to 1. So that is x plus 2y by 3 plus 3 z by minus 2 equal to 0. Okay, is equal to 1. I can multiply by 6. You can keep as it is now here. I can multiply by 6. So this is what 6x plus 4y minus 9z is equal to 6. Okay. So this will be the required equation of the plane. Okay. You may simplify this or you may not simplify, but it is better to simplify this. Okay. So for objective exam, so they will provide this plane then. Okay. So a plane, next example, a plane meets the coordinate axis at A, B, C such that the centroid of the triangle ABC is the point 1, 2, 3. Find equation of the plane. Find the equation of the plane. Find equation of the plane. Okay, solution. A plane meets the coordinate axis at ABC. Okay, so let a plane meets the coordinate axis at A0 0, B0 B0 and C0 0 C. Okay. then equation of plane is x upon a plus y upon b plus z upon c is equal to 1. We call this as 1. Okay, but the centroid of triangle ABC is 1, 2, 3. So 1, 2, 3 is equal to. So centroid means what? The average of the x coordinate, average of the y coordinate. That is what? A plus 0 upon 3. 0 plus b plus 0 upon 3. So 0 plus c upon 3. That means what? The sum of the x coordinate upon 3, sum of the y coordinates upon 3, sum of the z coordinates upon 3. So this is what? A by 3, b by 3, c by 3. So this implies that a by 3 is equal to 1, b by 3 is equal to 2, c by 3 is equal to 3. So this implies that a is equal to 3, b is equal to 6, c is equal to 9. Okay. So equation 1 implies. So 1 implies. We put the values of ABC in 1 now. We got the values of ABC in 1. ABC, right? So we put this value in 1. So this is what? X upon 3 plus y upon 6 plus z upon 9 is equal to 1. Okay. So you may keep as it is or you may simplify. You can multiply by 18. You get the required equation of the plane. Okay. So you can multiply by 18. So this is what? 6x plus 3y plus twice z is equal to 18. If you multiply by 18, because the LCM of the 369 is 18. So how to find the LCM? Take the biggest number, that is the 9. So this 9 is not divisible by 3, divisible by 3 but not divisible. So take a double of that one, 18. So see, now 3 is divided, 6 is also divided. So 18 will be your LCM and multiply by LCM. Okay, we get this. Now equation of a plane, equation of a plane passing through a given point, passing through a given point. Okay, here the equation of a plane, passing through the point, A, x1, y1, z1, and DRS of whose normal R A B C is A x minus x1 plus B y minus y1 plus C z minus z1 is equal to 0. Okay, so proof. We want to prove that this is the equation of the plane. Okay, so given that the DRS of normal to the plane R A B C. Therefore, the equation of plane is Ax plus By plus Cz plus D is equal to 0. Okay. So now we want to find the value of D only. We want to find the value of D now. Okay. So plane 1 passing through the point A. We have given the point. Okay. So x1, y1, z1. So this plane passing through the point A, x1, y1, z1. That means this point satisfies the equation of the plane. So therefore we have it satisfies the equation of the plane. So that is what ax1 plus by1 plus cz1 plus d is equal to 0. So this implies that d is equal to minus ax1 minus by1 minus cz1. Right? So this is the value of d. So what we will put in 1. We get now see ABC are known to you, x1, y1, z1 are known to you. That means this sum is known to you. That means d will be known to you. We will put the d in 1 now. Okay. So 1 implies ax plus by plus cz plus d. Okay. So that is minus ax1 minus by1 minus cz1 is equal to d. So this is what ax minus x1 plus by minus y1 plus z minus z1 is equal to d. So if x1, y1, z1 are given, abc are not given, then we have to find the value of abc. This is the form of the equation of the plane. Okay. So this is the required equation of a plane. This is the 1-point form, and it is called 1-point form of the equation of the plane. Okay. So this is very easy. If you understand the plane, then no problem for it. Okay. Find. So we take example. Find the equation of the plane which passes through the point a -1 4 and parallel to the plane twice x plus twice y minus 3z minus 1 is equal to 0. So you want to find the equation of plane passing through, and your plane is passing through this one. Okay. So you know that if two planes are parallel, then a1 upon a2 is same as b1 upon b2 is same as this. So that means what here? Okay. Solution. The equation of a plane parallel to the plane twice x plus twice y minus 3z minus 1 is equal to 0 is of the form. So it will not change the coefficient of x, y, z. It is differ by the constant only. So is of the form twice x plus twice y minus 3z plus d is equal to 0. You can take is equal to d or plus d is equal to 0. This is your required equation of the plane. If you get the value of d. So what is our aim now? We want to find the value of d. Okay. We are given one more condition is that your plane passing through the point this a minus 1 4. That means what? This a minus 1 4 satisfy the this equation. Okay. Plane 1 passing through the point a minus 1 minus 4 or minus 1 minus 1 4. Therefore we have what we have to do? We have to put the value of x, y, z as this. This is what. Therefore we have 2 into minus 1 minus 3 into 4 plus d is equal to 0. You will get the value of d now here. So this is what? Minus 12 plus d is equal to 0. So d is equal to what then? This is 16. D is 16. Therefore, required equation of the plane is just we have to put the value of d now here. So that is what? Twice x plus twice y minus 3z plus 16 is equal to 0. Okay, so problem is over. This is very simple problem. We'll make a note now. Okay. The equation of the plane passing through px1 y1 z1 and parallel to the plane ax plus by plus cz plus d is equal to 0 is very simple. This is what? Ax plus by plus cz is equal to, just we have to write the value of the point ax. So this is what? Ax1 plus by1 plus cz1. Don't take this is your new d now. This will be your new d. It is called differ by the constant only. Okay. So how to identify the two planes are parallel? So their coefficients of x, y, z are the same or multiplied by fixed number. Okay. So that means what? If a1 upon a2 is same as b1 upon b2 is same as c1 upon c2, then the two planes are parallel. Okay. So this is very simple way to find the equation of a plane passing through the point and parallel to the given plane. Just what? Write your x, y, z as it is, the terms of x, y, z as it is, and is equal to, just replace your x as x1, y as y1 and z1. Find this sum only, and this is what here the constant only. Okay. So this is what minus or plus whatever this is. Okay. So this is very important. For objective, okay, find the equation, find the equation of the plane, find equation of the plane which passes through, which passes through the point A 6 to minus 8 and DRS of the normal are 3 to 1. 3 to 1. Okay, so DRS of the normal to the plane are provided to you and 1 point on the provided to you. Okay, so what we will do, we'll directly write the solution now. Solution. The equation of the plane. So if there is a find, just remove that find only. Okay, so just write the equation of the plane which passes through the point this and DRS of the normal to the plane is okay. So what here? So these are your ABC. These are your ABC. These are your ABC. What? 3 to 1 are the ABC. So what? So 3 into x minus x1 6 plus 2 into y minus 2 plus 1 into z minus minus 8 become plus 8 now is equal to 0. Is equal to 0. Simplify this. So 3x minus 18 plus 2y minus 4 plus z plus 8 is equal to 0. So 3x plus twice y plus z. So here what? Plus 4 minus 14 is equal to 0. So minus 4 minus, this is plus 4 and this is plus, so minus 14 is equal to 0. So the problem is over now. So this is your required equation of plane. Very simple, because the DRS of the normal to the this ABC are the DRS of the normal to the plane. Okay, so two ways you can solve this. Okay, so we know that the equation of the plane passing through the point, not passing through the equation of plane whose DRS of the normal to the plane are what? 3x plus twice y plus z is equal to d, suppose. Okay, now you can find the value of d now. This passing through this point, just you can put here now. See what is it? This is what? 18 plus 4 minus 8 is equal to d. Okay, so this is what here? Minus 4, this is what? 14 is equal to d. So d is equal to 14 now. See, if you d is equal to what? 14. This is your required equation of the plane. Okay, so several ways you can do this one. Find the equation of the plane. Find the equation of the plane which passes through A 2 minus 3 1 and perpendicular to the line joining the points joining the points 3 4 minus 1 and 2 minus 1 5. 2 minus 1 5. Okay, solution. The DRS of the line joining the points A, I write A 3 4 minus 1 and B 2 minus 1 5 are what? 2 minus 3 minus 1 minus 4 5 plus 1, that is I have subtracted B from A, so this is what? Minus 1 minus 5 6, and I can write this is 5 minus 6. Okay, because there are two negative, so I will take this. I can multiply by fixed number. Even though I can multiply by 2 also. If this is 3 by 2 4 by 2 1, so I can multiply by 2 now. So that what? I can multiply by the fixed number. I can multiply by minus 1 here. I can multiply by minus 2. Doesn't matter for this one. Your DCS will be the same. TRS will be the same. Okay. So what is this? the plane is perpendicular to the line. Okay, so AB is perpendicular to the plane, perpendicular to the plane. Okay, so therefore that is AB is normal to the plane, normal to the plane, normal to the plane. AB is normal to the plane. Okay, so that means what here, these are the DRS of the normal. Therefore the equation of a plane passing through A. So this A is given, so we'll write this as P and Q now here. We'll write this is P and Q now. Okay, so PQ, we'll say PQ now. PQ is now, because A is already given, so you should give the other name. So we'll give the name P instead of A and B, we should give the PQ now. Okay, so passing through A, 2 minus 3, 1. Because what? The A is already provided to you, the name is provided to you. Okay, so don't use this A and B now here. Okay, okay, passing through the plane, and DRS of normal to the plane are 1, 5, minus 6 is given by, so DRS are given to you, this is what, 1, 5, 6. Okay, so this is what, 1 into x minus 2 plus 5 y plus 3, I have to change the sign, minus 6 z minus 1 is equal to 0. So this is what, x minus 2 plus 5y plus 15 minus 6z plus 6 is equal to 0. So this is what, x plus 5y minus 6z. So your constant is what? So this is what, 13, so 19 plus 19 is equal to 0. Okay, so I hope that you understand all those things. Okay, so now we will stop here. Thank you.